All right, we're back. We're on page 2 of notes 14 of Calc AB, and we are talking about approximating definite integrals using sums, rectangles, trapezoids, left sums, right sums, midpoint sums, trapezoids. That's probably what I should have said, but it took a while to get there, but we got there. So what are we really doing? We're really like pretending that some messy function is very geometric. We're pretending it's just made out of rectangles or made out of trapezoids, because that's easier to deal with. And sometimes in life, you accept that you're not going to get the perfect answer, you're going to get a good enough answer, and it's going to be timely and whatever. So let's take a look at this problem and see what we can do. A car is traveling at 36 meters per second when the driver continuously brakes to a stop in 5 seconds. Okay, the table shows the velocity time data. So at t equals 0, you're going 36, and then 1, you're going 30, 2, 23, and so on. So I think it's useful to make a scatter plot. Also, the question says to do that. So let's. All right. So what kind of scale can we use here? I don't know. 1, 2, 3, 4, and 5. And then I'm gonna go by like 5s, I think, because it's like they're all right around a multiple of 5. So I'm gonna count by 5s. Say 5, 10, 15, 20, 25, 30, crud. We're going up. And 35, and we still have to go higher than that because it's 0, it's 36. But all right, that's fine. You know what? I can shrink it. So let me do that. Shrink you down. Shrinky dinks. Anybody ever play with those? I love those. Those were crazy. They're like, what are they? There's some sort of plasticky thing that you get, and it's like a 8.5 by 11 sheet, and you color it in. Like it's got like a black line thing on it, and you color it in, whatever you want to color it. Then I think you cut it out, and then you put it in the oven, or your parent or some guardian, some responsible adult puts it in the oven, because you do this when you're really small, and it shrinks. And it looks awesome. It's like your like kind of like gross coloring gets much nicer when you shrink it down. Shrinky dinks. They're very cool. Try them out if you never tried them. I don't think you'll be disappointed even like as an adult if you're an adult. I don't think I would be disappointed to play with Shrinky Dinks right now. Also, that name, you get to keep saying Shrinky Dinks. All right, 0.36-ish, 130. 2 is going to be 23, so like, I don't know, here-ish. 3 is going to be 15, so like it should be almost perfect. 4 is at 6, and then 5 is 0, so because you stopped. Okay, that's it. Oh, and connecting the data points. All right, let's connect the data points. So I'm just going to connect them with straight line segments because I don't know what else to do. I mean, I probably shouldn't do that because there's no way this is like piecewise linear. But you know what? That's all right. Okay. So there you go. That's our velocity time graph. Given the situation, what type of function is the velocity function? I feel like the answer to this is a decreasing function because you're continuously braking. Decreasing. So one of the questions we're going to be answering often is like, are we getting an overestimate or are we getting an underestimate? So here we want to give a lower estimate and an upper estimate of the distance the car traveled after the brakes were applied. So I'm going to use either left or right sums. They're called Riemann sums, by the way, when they're rectangles, after I think it's Bernhard Riemann, who like, I mean, that's like to me, that's like a classic German name. I don't actually know that he was German. I'm going to duplicate this so that I can do like 2 different things. All right, so the first, there, done. Okay, first thing I'm going to do is I'm going to try to get a lower estimate. All right, so on this first interval here from 0 to 1, I want a lower estimate. I want to be definitely under the correct amount. So I could do a right rectangle, but you can see that's like over by a bunch. So instead, I think I'm going to do oh my God, that was a left rectangle. Left and right, not my friends. I'm going to do a right rectangle, and you can see that I'm under by some. So right rectangles are the way to go. So for my lower, this is my lower. I'm gonna do right rectangles. I'm gonna do them in like this color. And I'm gonna see if I can like get them to snap kind of quickly. I can like resize it once it goes. Oh, I see what the problem is here. I'm not perfectly vertical from the thing. You see the problem. It's my lack of ability, mostly. Okay, so these are our rectangle. Let's try to get this, I don't know, something like that. Okay, I don't know why that happened. Okay. What the heck? Am I doing this wrong? Why does it keep turning into, not that you would know. I mean, I guess you're watching, but like, there we go. And let's move you. Oh wait, that was like a good way to do that. Now what happens with our last rectangle? Our last rectangle doesn't even exist. It's just there, right? So now my lower estimate, what is this? They're all by ones, right? So this is 30, 20, I don't know these numbers. 30, 23. That's really 23, I thought. 15, 6, and 0. Okay, so what am I doing though? I'm doing basically a definite integral. I'm doing the integral from 0 to 5 of v of t dt. And I'm going to say that's approximately, so this is lower, 30 plus 23 plus 15 plus 6. Should we add those up? 30, 21 is 51, 71, 74, I think. 74. And then it's meters per second, so it's going to be in meters. All right, that's my lower. Upper should be a different color, obviously. What color though? This color. Upper. So we're going to go 0 to 5, v of t dt, approximately. You know, I think that this should just be like a colon or something. I don't want to mislead you. All right, upper. So this time I'm going to do the left sum. Let's see how poorly I do on this. Oof. Yeah, I hate this. Let me see. Because if I can just like make one, I could potentially like just duplicate it and move it around and like not waste everyone's time. All right, there, duplicate. Whew. Check out this speed upgrade here. Duplicate. Some of my spacing is way off. And then wait for it. Oh, I did all of them wrong. Crud. So good. Oh, good grief. All right, hold on. We got to erase every. Here we go. Okay, so that's the one that messed me up. Maybe. Golly, those should not do that. Because we want the left endpoint should always be the biggest one for this. I should have taken more time when I made this, so it like would work a little better. But I think you're getting the idea. I hope. I don't know. This one I'm not happy with, like even a little bit. Can I copy? Okay, I duplicated that, but can I like do something with it? Oh, this is going so great. You know what you're getting? You're getting messy rectangles. What are we doing? We're doing upper. There. Whew. Let me show you how I usually do this, actually. Here we go. It doesn't need to look good. Here we go. There. I hated that. Every part of that was terrible. All right, so what are each of these? This is 36, 30, 23, 15, and 6. So this will be approximately 36 plus 30 plus 23 plus 15 plus 6. Okay, and then that's actually equal to, I don't know, 66, 89, 99, 104, 110. So 110, I think. 110 meters. So 74 meters, 110 meters, somewhere in between there for sure. So like, I feel like I did show these. Now the difference between them is I kind of need a third graph, and I just hated that whole process so much. I don't know if I have it in me. All right, hold on. Let me move this over. Let me duplicate this. This is like a 200-hour video because I can't draw rectangles. So you're welcome. And then, you know, all right, I'm definitely going to stop after this though, so don't worry that much. Here we go. Ready? Let me just clear out that. I'm going to put in the lower ones, right? So here, 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 and then it was like here, right? Okay. So what is the difference between them? Well, the difference between them should be, I will try to shade it in like red, like this. These two rectangles have that difference, and then this difference, and this difference, this difference, and that difference. So what do those add up to? They go from 0 to 36, so it should be 36. If I look here, 110 minus 74, 10, 6, and 36, the difference is 36. Isn't that crazy? I don't know if that's crazy or not. I don't know if you think that's crazy. But you can see the difference between them because it's just the difference between the left rectangle, the right rectangle, whichever one's bigger minus whichever one's smaller. And it's literally just this minus that, it turns out. In this case, is it always the case? I don't really know. Is that a big idea that you really need to focus on? Definitely not. So don't worry about that too much right now. And yeah, all right, we're done. We're done. I'll be back in the next video. I'm gonna do a better job on rectangles, and I will see you there.